Assalamualaikum guys, welcome back to my YouTube channel ChrOmaTogRaphY. I hope that you all are doing good, and I also hope that you have already watched my previous videos. If you don't watch it, go and watch them completely, like them, and don't forget to subscribe my channel. So let's start our new topic, new video, which is the terminologies used in the column chromatography. If you have already watched my previous video, which is then it is on the topic of the column chromatography, which is the type of the chromatography. So our new video is on the terminologies which are used in the column chromatography. First one is the chromatogram. A plot of detector's signal as a function of time or volume of eluted mobile phase is known as a chromatogram, and it consists of a peak for each of the separated solute bands. This one is the typical diagram of the chromatogram. Another one is the retention time. The retention time TR is the elapsed time from the introduction of the solute to the peak maximum. And the retention volume, the volume of the mobile phase eluting between the solute's introduction and the appearance of the solute's peak maximum. This is known as the retention time V, retention volume VR. Another one is the baseline width, the width of the solute's chromatographic band measured at the baseline. It is determined by the intersection with the baseline of the tangent lines drawn through the inflection points on either side of the chromatographic peak. Void time, and it is the time required for unretained solutes to move from the point of injection to the detector. Void volume, the volume of the mobile phase needed to move an unretained solute from the point of injection to the detector. Chromatographic resolution. Resolution is a quantitative measure of the degree of separation between two chromatographic peaks A and B, and its formula is here given below. Further, we have the resolution be improved either by increasing the delta TR or by decreasing the width A or width B. We can increase the delta TR by enhancing the interaction of the solutes with the column, or by increasing the column's selectivity for one of the solutes. These are the diagrams of the resolution. Further, we have the capacity factor, a measure of how strongly a solute is retained by the stationary phase. The distribution of a solute as between the mobile phase and the stationary phase can be represented by the equilibrium reaction. This is the equation 1. Kd is equal to S over Sm, and D is equal to Ss dot Sm dot. Conversion of the mass requires that the total moles of the solute remain constant throughout the separation. Thus, equation 2 becomes moles S dot is equal to the moles Sm plus moles Ss. And further, we have equation 3. Fm is equal to moles Sm divided by the moles S dot is equal to the Vm divided by the Vm plus dVs. So equation 4 becomes Fm is equal to 1 over 1 divided by the 1 plus d into Vs divided by Vm is equal to the 1 divided by 1 plus K naught, where K naught is the solute's capacity factor, and it is equal to the d into Vs divided by Vm. Our equation 5 is U is equal to the L over Tm, and equation 6 is V is equal to the L over Tr. Equation 7, V is equal to the UFm, and equation 7 becomes that L over Tr is equal to L over Tm into 1 divided by the 1 plus K naught, where Tr dash is known as the adjusted retention time, and it is defined as the difference between a solute's retention time and the solute's avoid time. Selectivity factor, ratio of the capacity factors for two solutes, showing the column selectivity for one of the solutes. Then we have the band broadening, the increase in the solute's baseline width as it moves from the point of injection to the detector. Further, we have the temperature programming, the process of changing the column's temperature to enhance the separation of both early and the late eluting solutes. Further, we have the gradient illusion, the process of changing the mobile phase solvent strength to enhance the separation of the both early and the late eluting solutes. Further, we have the Van Demeter equation, an equation showing the effect of the mobile phase flow rate on the height of the theoretical plate. And further, we have the fronting, a tail at the beginning of the chromatographic peak, usually due to the injecting too much sample. Fronting at the most often the result of overloading the program with the sample, and at the end we have the tailing, the tail at the end of the chromatographic peak, usually due to the presence of the highly active sites in the stationary phase. Tailing occur when some sites on the stationary phase retain the solutes more strongly than the other sites. These are the diagrams of the fronting and the tailing. So guys, I hope that you clearly understand the terminologies which are used in the column chromatography technique. So like my video, subscribe my channel, and wait for other topics of the chromatography. Take care. Allah Hafiz.